Okay, guys, I'm going to run through a few of these. I will not do all of these. Obviously, this one is not on the test tomorrow, so I'm not going to do that top part. We do have inverses of functions, so let's start first with, I don't know, we'll do 6 and 8, something like that. 6 and 8. So first thing I need to do is get rid of the 1/3. To get rid of the 1/3, I'm going to, well, 1/3 really means cube root, so I'm going to end up doing the opposite of that, okay? And so the opposite of that is to cube both sides, because that would get rid of that. And if I do it over here, that's not multiplying by 3, that's raising it to the third. So it's x to the third, because we switch x and y for inverses. 4y minus 9 over negative 3. So now what I'll do is I'm going to work on getting y by itself. So multiply by negative 3. Negative 3x to the third equals 4y minus 9. Add 9. Now I log both sides. Log negative 3x to the third plus 9 equals y log 4. Okay, so then I'm going to divide by log 4. And when I divide by log in a number, what happens is that ends up turning into the base with what's in the numerator. So log base 4, negative 3x to the third plus 9. Okay, so let's go back over this. This was exponential because there's an x in the exponent. Now it turned into a log because they are inverses of each other. So if we look at number 8, it's a log, so it's going to turn into an exponential. So first thing I want to do is divide by 9. So anytime I want to turn it into exponential, I'll go ahead and switch x and y too. Before I turn it into exponential, you always want to isolate the log. So I divide by 9, went away. Now what I'm going to do is rewrite it exponentially. So it's 2 to the x over 9, 2 to the x over 9 equals, it's our little loop trick of rewriting. So this one comes from 16.3 and this one comes from 16.2 if you're going back and looking at the notes. So then I'm going to subtract 5. So 2 to the x over 9 minus 5 equals y to the third. Sorry about that. That should have been a y. So then, to get rid of the 3, I'll cube root it. So y equals the cube root of 2 to the x over 9 minus 5. Okay, so it started logarithmic, ended up exponential. It's still exponential because there's an x in the exponent. And I think that's it. Let's look at number 11. So number 11, the best way to rewrite this, if you notice, all of their exponents are divisible by 4. So when I condense this down, u times w over v, this v, well, I'm going to raise it to the fourth, but the v will have a 5 because this is the better way to write it. There's another way, but I'm looking for the best way. And so this is the best way because this is the most, sounds weird, but the parentheses, this form is the most simplified form. So let's do number 14. Okay, number 14, what I want to do is I want to get these to all have the same base, okay? Because I noticed that the bases are all some kind of factor of each other. So then what I'm going to do is 16 can be 4 squared times 3n, what was already up there. This 16 can be also 4 squared times what was already up there. And then this is still 4 squared, or it's not 4 squared, it's 4 cubed. So that one stays the same. So according to my laws of exponents, when two things are multiplying, I'm going to add their exponents. Okay, and then I would, sorry about that. Then this is 2n equals 3, n equals 3 over 2. This came from section 16.2. You can actually check all these if you wanted to. You don't have to, but you can. Alright, so on the back, I did it on the review, but 15 through 18 is not on part 2 of the test. You already got tested on it on part 1. So I'm going to jump down to the log equations and then some properties, using the properties. So we'll do 19 and 21. All right, so and one like this. So notice that this 2 doesn't have a log, so I can't just drop the logs and solve. So instead, I'm going to bring together these two logs. So these two are adding, so I'm going to multiply what's behind each log, set it equal to 2. So now I rewrite it with my loop trick. 6 squared equals all this. So 6 squared, 36, equals 6x plus 2. So 6 squared, 36 equals all that, distributed. And now I just need to get x by itself. So I would subtract 2. 34 equals 6x. Okay, and then it's like 17 over 3. You'll leave your answers in improper fractions is okay tomorrow. You can, what you want to make sure to do is you look at the answer, doesn't give me a negative inside, then you're all good. Alright, so next one has subtraction. So what I need to be careful about in doing is that I'm going to end up dividing what's behind each log. Okay, so they divide because they're subtracting. Loop trick rewrite. 4 squared equals 2 over 3x minus 6. Now this is where most people get stuck. I like to. We'll make that a 16. 4 squared. So I like to make both sides fractions, and then I like to cross multiply. So 16 times 3, I need a calculator, I'll do it real quick. 48x minus, I think it's 90, no, I'm not to do that. Sorry. 96. Okay, I knew it was 90 something. Equals 2. So when you have a fraction and a non-fraction, make them two fractions, cross multiply. So then I add 96. 48x equals 98. And then you'll reduce it. So when you divide it, I believe they're both divisible by 2. So that's 49 over, so it was 98 over 48, which ends up 49 over 24. I don't have a, I'm pretty sure. I'm trying to go too fast, probably. Alright, so let's look at number 25. The one thing up here, there is no problems that have all logs. When you have all logs, once you combine them to have one log in each side, so this is 16.3, whenever you combine them to have one log on each side, then you just drop the logs and solve. So, okay, so 25. So I'm going to use these values. So then we were like, wait, but 5 isn't up there, but yes it is. Log base 5 of 5 is 1. And then 16 will be subtracted, so log base 4 squared, but that's really 2 log base 4. And according to my table, 0.9 is log base 5 of 4, so minus 2 times 0.9. So that's 1 minus 1.8. 1 minus 1.8 is negative 0.8. Just don't forget, you know, to use the base as a value. I'll be here in the morning if you have some questions. No calculators tomorrow. I think that's it. I also will have the review if you need to print another review. It's on Canvas as an assignment if you want it.